Hey folks, let's take a few moments and talk about the difference between standard notation and scientific notation. Standard notation is what you're used to doing, writing a number out showing all the zeros, all the places that the number has. Scientific notation is a way to take a very long number with lots of zeros, it can be big or small, and to write it in a more condensed form. So it's more convenient. In science, we frequently have to measure things that are very small, like the mass of one carbon atom, measured in grams. This number is so small, I don't even really know how to say it. All I know how to do is read it, 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 form. Scientific notation is a way to write that exact same value, but in a much more compact form. It looks like this. 1.994 times 10 to the negative 23rd. Yeah, it's a lot smaller. Sometimes we have to write very large amounts, like the number of hydrogen atoms in 1.01 grams of hydrogen. Now that's a really small mass. It's like 1.5 Cheetos. But hydrogen atoms are so small that again is a really long number with lots of zeros. I don't even know how to say it. I mean, here's hundreds, thousands, millions, billions. Is it zillions next? Trillions, then zillions. I don't even know. So many zeros. Scientific notation takes that exact same number and writes it in a much more compact form. By the way, it's just coincidence that these both have 23 as their exponent. That's not always the case. I just happen to pick two numbers that work that way. Okay, so now let's look at this in more detail. When I took that first number and turned it into scientific notation, here's what I did. I looked at the original amount and I looked at the non-zero part of the number. Then I placed a decimal so that that was between 1 and 10. So let's think about the places where I could have put the decimal. I could have put it between the 9 and the 4, but that wouldn't give me a number between 1 and 10. That's 199.4. I could have put it likewise between the 9s, and that gives me 19. That's not what I want either. I therefore am putting the decimal here between the 1 and the 9, and that gives me 1.994. That is a number between 1 and 10. So I took the non-zero part of the number and I placed the decimal to turn that into a number between 1 and 10. I'm well on my way to writing this in scientific notation. The next part is the times 10 to the. First of all, it is a negative exponent if you are representing a very small number, a number less than 1. Positive exponents are for values greater than 1. Now, the number that becomes the exponent, what I have to do is look at where I placed the decimal, where it originally was, and count how many moves that is. In other words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. That's the number that goes there. It's not the number of zeros. If I counted the number of zeros, there are 22. But then I would have left off this move here. So 1.994 times 10 to the negative 23rd is the way to represent that in scientific notation. Let's look at the other one. Again, I take the original number in standard notation. I find the non-zero part of it. I place a decimal to change that into a number between 1 and 10. This non-zero part I would read as 6,022. I'm going to place a decimal, so that becomes 6.022, or a number between 1 and 10. This right here. Now I count from where I put the decimal to where it is originally. I don't see the decimal. Well, that means then it's here at the end. Just like 5 is the same as 5.0. Right, the decimal is there. And so I'm going to count how many moves the decimal. Well, if I counted all those, that would be 23. Again, it's not the number of zeros, it's how many moves of the decimal. And that is the value that goes here. Okay, so what does that mean? That means if I took 6.022 and I started multiplying it by 10, I know that that would move the decimal. Multiplying it by 10 once turns it into 60.22. Multiply that by 10 and I get 602.2. Multiply that by 10 and I get 6,022. Another multiplication of 10 starts tacking on a 0, and another, and another, and another. If I did that 23 times, I would get back to the original amount. So scientific notation is a way to take very long numbers and to shorten them up. What I do is I look at the non-zero part of the number, I place a decimal there to make it between 1 and 10, and then I count how many moves of the decimal and place that value as the exponent. If the original measurement is less than 1, it is a negative exponent. If it's greater than 1, as in 6,022, however many zeros, then the exponent is positive. Hope that helps. Watch it again if you need to.